Welcome to another episode on the Bead's food ordering app. Here we're cloning the McDonald's food ordering system, and we've put in some of their menu, and we're testing it by going through and selecting some products, adding them to our shopping cart, and then we're going to go to the payment and let's add another credit card on file. And so we're testing the data input fields and the logic therein, to make sure the card has the right number of digits and the expiration date is in the future, not the past, and that the card security code has the right number of digits, and that all the required fields are put in. So this is your normal input field that you see in every web form, and of course it's in the app because you're going to have to be able to add credit cards. Now, when you're testing software, one of the most important things is, can you reproduce the problem? And here I've put in intentionally an expired credit card, and I'm going to correct it and go on, and then I add the card. But notice there's a freeze button down in the lower left corner. If I press the freeze button, then I can now go back in time, and I can use the thumb slider and undo back to the beginning of the program. This is baked into every copy of Beads. So every program you write in Beads has time travel built into it. And you can freeze, go back, mark a spot, truncate the history at that point, continue on, or just replay it just to see how it looked. This is a fantastic feature, and time travel is going to be the subject of this week's episode. Let's look at a product that I built 20 years ago called Flying Colors. It's a children's painting program, probably the best one ever made for teenagers. It consisted of a few thousand pieces of art, hundreds of backgrounds, and a general purpose bitmap painting program. So it's basically a single layer version of Photoshop, but it has a lot of clip art built in. Now, this program is not being operated by the user. This is actually a playback of a lesson. So this is a narrated instruction tutorial that was built into the product, and so the product was capable of self-operation. You could do some work in the program, and then you could actually replay. But it wouldn't just redo your work like Photoshop does. It would actually ghost click on the interface. You could actually see exactly how someone made a painting. So here in this particular case, we're building a wizard's laboratory, and we're making them out of all these different pieces, and knowing how to use these pieces is tricky. So this one was actually made by the artist Mark Ferrari, who's a very famous pixel artist who did Loom, Monkey Island, many of the greatest LucasArts games. You don't often see self-operation in products. It basically involves having the program have a monitor inside itself that is watching the sub-program operate and tracks what you've done. And you'll see in the Beads how we accomplish this for testing purposes. Here's another product that used the same technology. This was a DragonBall Z painting program. DragonBall Z is one of the most popular anime and comic book series in Japan, and it's actually known all over the world and has sold more than 100 million copies. It's a huge worldwide phenomenon. I'll just show you a few seconds of what the DragonBall program looked like when it was running self-operation. Here we're making a painting, and we're drawing in the little stars and then adding the various characters. The point of the self-teaching is that it's a great way to do instruction. Okay, now let's get back to Beads. Here, let's look at the clock program, and I've added some buttons at the bottom which show you how you can control time. I've added a button at the bottom that says fast, and then there's 11:59:55, and that is a jump button where it will jump the time to 5 minutes before midnight. And when I click the fast button, the clock runs at 10 times normal speed, and then I can go back to normal speed. And when I click the 11:59 button, it will jump to this particular moment. In Beads, you have control over how fast time elapses. You can slow it down or speed it up, and you can set the effective system clock so you can test things that happen at specific times. Now let's go back to our cycler utility, which allows you to run a program inside another. You can pick different devices that you're trying to emulate, but now we click the freeze button at the bottom, and now we see a time scrubber, and we can move that to the left, and there are 56 different micro steps in this particular session that we did, and you can see that as I move the slider, the clock is moving back and forth in time. When I click unfreeze, I go back to time where I left off. If I click the Mark A button, I actually mark that point in time with a little marker, and then when I freeze, I can go back to that specific time, and it'll jump back to that moment. This is very useful for testing. Let's say you have 3 alternatives. You mark that moment just before you make a choice, and then you go in tunnel A, you do that, test that, then you go jump back to A, then you test B, and then you jump back to A again, and you test alternative C. In this way, you can test many different variations of a product, the different choices that you have, without having to redo a whole session. It's a very useful tool for testing, and because we have a save button, you can actually save that file, and it's a very compact file, and you can email it or send it electronically. Anyway, this just skims the surface of what Beads can do in terms of rewinding its state. Fundamentally, it is a tracked mutable state language, so you can go backward and forward in time, and this is not some special debugger. All of this is available to your program itself.